adjust a little bit on the left here. That's cool. All right, so I've put this together a little bit. This is something we're actually looking at, in terms of traffic control, at least for the control plane, and also for other components that we're using, either like Elasticsearch or InfluxDB or Grafana or these things, because they're all kind of running in Docker today for us, and well, except traffic control, of course. And we're trying to either scale those components or trying to also not be sysadmin anymore or deal with infrastructure, at least on the control plane. So, oops, that's nice. There you go. So Openshift, who's heard about Openshift or, all right. So who's used it in the past? Nah, not much, okay. So basically it's a nice UI, or, at least they've put some features on top of Kubernetes. Basically that's what runs in the background. And so Openshift is a Red Hat product, although they do have an open source project, which is called OKD, right? And I think I've got a web page here. It was called OpenShift Origin before, and now they renamed it to OKD. So there's a free version that you guys can use to test, and I'm going to make a demo of this today. But basically, it is orchestration for containers, right? It actually enables auto-scaling based on resources utilization, either memory or CPU. It does have some small capabilities into health checkings. Whenever you bring up your container, for example, it can verify if it's up, right? And it can also have liveliness checking afterward. So if it dies somehow, then it can actually restart it. As I mentioned, there's a free version. It's able to create routes, and I can explain a little bit later, but this place, like, you can actually expose URLs for your application directly, and it does handle TLS natively as well. And so why are we using it? Well, there's the previous reason, but so we don't want to build infrastructure for the control plane anymore, and we don't want to be the sysadmin, but we'd like to more work on the application. It is kind of our next step to automation. So instead of like creating playbooks to install components on a VM, for example, or an LSC containers, then we can actually just bring up a container. It comes natively with CI/CD, where you can actually build your application directly from GitHub, and it's actually using Jenkins in the background. So outside of traffic control, most of the components that we use, like Logstash or Telegraph or all these kind of things, they're all available in Docker images today. So that makes it easy to deploy. So as I said, easy to manage. And it comes with some load balancing features natively where, for example, you can actually bring up traffic ops, the API, like 3 or 4 times, but you expose only one endpoint to it. And so it does actually, I believe it does use HAProxy or Nginx to do their load balancing. So there's a couple challenge, at least on the traffic control side. We don't have today any Docker image available on Docker Hub. I believe we don't, right? We have to build it ourselves, and they're kind of based on the RPMs. I mean, it's not that building it on the RPMs is the problem. Most of the Docker image over there are built on top of RPMs. And also, there's a lack of maybe service discovery, which is something that you guys taking care of, like with the enroller, for example. I don't know if we should develop something where if we actually bring components in a Docker environment where we can have maybe a console or something to take care of this. I don't know. So the infrastructure is fairly static. If you want to provision a traffic monitor, then you have to put it in traffic ops first, and then you can actually provision it. And the same thing for everything else. I mean, it's not because it's a bad way, but it's kind of it's fairly static. And of course, when you go in that kind of like PaaS or OpenShift or Docker, then most of the configuration they want you to do it through environment variable, right? And this is something where we should probably think about reducing the number of configuration file that we have on disk, and maybe configure a little bit more through environment variable. Something that can be handled, by the Docker container with specialized script. That's something we should think about. So, I mean, that's about it for now. So what I'm going to do here is I'm just going to do just an Elk Stack demo just to bring up on OpenShift. Just something easy I thought about doing just because I didn't have any of the traffic control stuff. I thought about doing traffic stats, but I didn't get there. If you go on the web page again that I had here, it says you can actually try this out. It's fairly easy, and all we have to do is actually OC cluster up there's of course a download you need to do. For those that's got a Mac, you can just do brew install Openshift CLI. I think I've got this one here, right? And that will actually install the OC binary. So I'm now just going to bring up the cluster. And by the way, when you're actually working on a laptop or something like this, I mean, using Docker Compose is fairly easy, right? I mean, this actually adds a lot of overhead. But when you think about deploying in production, for example, and you have like 30 machines running in the Openshift cluster, now it's like your resources can be scaled pretty good there. So I'm going to bring. Oh, am I on the right directory? Yeah. Everybody see this pretty good, or should I zoom this? All right, this takes about like a minute or two, and this brings the whole cluster. It's actually going to make available the OpenShift UI via xip.io using the localhost IP, which is pretty convenient. So, and then once that cluster is going to be up, I'm going to create a new project, and it's going to be called Elk Stack, and I'm going to bring up Elasticsearch, and I'm going to bring up Kibana so we can actually connect to it. And once I do this, I'm still connecting to my VPN, I'm going to expose Kibana through a URL, and it's going to create this one here, basically. Oh, actually, this is really, it's going to be Elk Stack. All right, cool. Because it's based on the project. So let's see if that's not done yet. And once I actually build the Elasticsearch in Kibana, then I'm going to bring up Logstash from our production Kafka servers, and it's actually going to fill up all the traffic router logs into Elastic. Any question while this is going up, or?
How do you compare OpenShift to, say, Kubernetes?
So it's actually running on top of Kubernetes. So you don't have to deal much with the templates if you want. I could actually, what I'm going to do, I'm going to actually provision all this stuff through CLI, but we could actually do the same thing with the UI, and it's fairly easy. All right, so the UI is up, and we're going to go to this URL. All right, and it created a user that's called developer. I'm going to use this one by default. And the password is password. All right, and that's the default UI that comes back, that comes in there. You can actually create a project. For example, I can create a project called Logstash. I'm just going to create this one for fun here, right? And you can actually go in and you can actually deploy your image. And there's images that are available, but then if you want to deploy directly to something like InfluxDB, then you would actually just call InfluxDB latest, for example, and you actually look it up. And one thing it's going to tell you, wait a second. Is that better? All right, is that, you see this thing here? It says InfluxDB latest is running as root user. Most installation of Openshift, the folks can actually lock it down, and this actually is not going to be allowed to run as a root user, so you got to be careful about this. So whenever we build Docker containers, let's try not to use the user root, just because some system might actually not allow them. And so this one, there you go, InfluxDB is created, and it's available. And it's actually exposed on port 8086. All right, so anyway, I created InfluxDB in the Logstash project, but it doesn't matter, we're gonna switch projects soon. So I'm gonna go in the CLI here using what I have here. All right, let's create this project, right? Once it's created, it's here. If I go back, it's gonna be created on the UI. Now I'm gonna deploy Elasticsearch. Now it's going to tell me, all right, expose port 9200 and 9300 in case you want to run a cluster in there. Then I'm going to actually create Kibana, which by default will connect to Elasticsearch :9200, which is available from inside the cluster directly. So they do have some DNS stuff that makes magic happen. If I go on the other side here, you're going to see Elasticsearch and Kibana. Right? You can actually go in there in those containers and see the logs. And this one's actually up and running. And for those that think like, well, I'm actually losing all my SSH connection and everything, there's actually ways to actually hit terminal, and you're directly in that container as well. So you can actually debug stuff and everything. So now that we have Kibana, I could actually, sorry, I'm going to go back here. You can actually expose the URL using that command on the CLI, or actually you can go right here in routes, and I say I want to create a route, and then my route's going to call Kibana. I want it to be on the service Kibana on port 5601, and somehow you can actually secure the route if you've got TLS and everything, although today I'm not going to do that. And you create this route, and I believe that if I actually now click on this URL, it's going to bring me directly in Kibana and Elasticsearch, and it's up and running. I mean, you could do the same thing with Docker Compose, right? And bring both of them, except maybe the route piece of it. So now that I've got this running, right, of course, if I go discover, I've got no data. So what I'll do next is I'm going to create the Logstash configuration, which as a config map, I'm going to show you how this works. But to make this easy, I've got these commands here. And I've got this directory on my hard drive. And I've got the config directory, and it actually contains my configuration for the JVM options for Logstash. This is not something that you have to do, although when you actually enable pipelines, you need to be able to tell where your configuration is. And there's a way where if you have the ECE installation or the cloud installation of Elastic, you can actually provide a cloud ID, and you just provide this as a parameter, and it goes and gets your pipeline for Logstash. And then I also have my pipeline for traffic router here. And it basically provides me the input for Kafka, the filters, and the output to Elasticsearch, which is port 9200 here. And I also have the template to bring it up in Elasticsearch. So those IP addresses shows as IP addresses, for example, in integers as integer. So I'm going to bring this up. All right, this one here. This is the config. And I'm going to import the pipeline. And if I go back in the UI, right here, the console, resources, you're going to see those config maps got created. For example, I've got my pipeline, it's got all my information, right? And I've got my configuration as well for Logstash. And if I go here, I'm going to load this Logstash deployment config. And this one, I can actually do all this in the UI, although I've prepared this one where it's going to actually mount these config maps as directory in the container file system itself. So Logstash can start and actually start consuming the data. All right, where is this one? And now it's created. Now we're going to go back and see what it did. I've got this Logstash resource in the configuration. I can see that my configuration data, this config map here, got loaded or actually extracted like in the hard drive at this exact location, in the pipeline, actually in that exact location. So if I go in my container, oops, history, container, terminal. Oh wow, that's great. Logstash pipelines. Oops, that's a directory. Right, you're going to find my two files that are actually extracted in there. All right, if I go back in overview, and if I look at my system usage, you're seeing like, my CPU is used quite a bit by Logstash. And if I go in Discover, of course, it's not there. So I've got to create my index pattern. And it says like, well, there's actually an index in Elasticsearch created. I'm going to go and type this in. Next step, pick up the timestamp. And my field should all show up. Now, if I go and Discover, I should see that my logs are actually coming in. And with the proper, integer and everything. Let's see, actually the IP address is wrong. I guess I didn't have those in my template. But that just shows like, how easy it is to build a Elk Stack using Openshift. I mean, it's as easy with Docker Compose, but now you get a little bit more values by actually being able to expose routes, for example. Now let me stop this because if I go in Logstash here, there's deployment. You see there's actually one pod running. Actually, I could spin off like another one with the same exact configuration. And now it's going to create like a second Logstash container with the same exact configuration. So if you have like, for example, Kafka, you have like 16 of those partitions, then you can actually start 16 of those Logstash, and it would just run like this. There's also where you can actually add an autoscaler, and it would actually be based on, all right, what's the number of pods that you want to run as a minimum? For example, VP1 got 6.
Does it know about your airline hardware? Like,
No, it doesn't
try
really.
to do 1,000 of these, you probably totally overload your hardware, right?
You could, but then you got to think about, well, if you could say like I'm only going to allow one CPU for each Logstash or 4 CPUs, for example.
1,000, you need 1,000 CPUs.
Yeah, exactly.
If you
But
have 28.
yeah, so it depends on your who actually deployed your OpenShift cluster and how many machines they've got, right, and what they actually allow you to do. Right.
So
So
OpenShift does know how many cores you have. And all that.
Yeah.
Okay.
yeah, and so it's by project usually. So
So when you spin up that second container,
yeah.
how do I slightly change the attributes on the container? I'm assuming through the environment variables.
So it's got the same configuration, right?
Yeah.
Same exact
I
thing.
want to tweak that on the fly before I spin it up.
I don't think you can, because this is like a pod that you're actually replicating in your cluster. It has the same exact configuration. So what kind of things you'd like to change, for example?
I'm sorry. What's that?
You'd like to change what? Configuration or?
Well, yeah, like let's say this is a thing that has a connection pool in it. And
Yeah.
All the other instances of running have a connection pool of 5.
Yeah.
Maybe I want to spin up one with 10. So how do I tell that container?
So then you would duplicate a container that's not the same, right?
Yeah, but I mean it's like 99% the same, right?
Yeah, so I don't think you can actually do this. You would need to create another like a deployment, for example, for a new configuration.
In the concept of immutable infrastructure, I mean, there is no variance between
Yeah.
your images. They're exactly the same.
Yeah. So it's just like to scale the same exact application. That's, for example, you have traffic ops. Well, it's the same configuration, right? I want to run 3 traffic ops. I want to expose it to a single URL, right? But it's all the same thing. Then you would actually scale it this way. So I'm just going to show you, like, all right, so we got 2 pods running, right? And here they are. And so you can actually now, how you actually shut this down, and you actually scale it down to 0. And it will actually destroy them both, and then your CPU should go down at some point. Yeah. So if I go back here, there you go. So I ingested a bunch of events on my laptop on Elasticsearch. So there's so yeah, I was actually going through autoscaler. So basically, you can set like one minimum of 1. I've got a maximum of like 16 partition available in my Kafka topic, for example. Then that's what you want to set it up. So it could actually, like, I mean, I don't know why you would want to scale it up and down, because you could just like, well, I want 16 all the time, right? But if you think about it, you might say, well, I want resources to be free in the morning so I can actually run some other task, right? So it doesn't use all my CPU during the day. Or actually, because it does reserve CPU resources. If you tell us, like, well, use like 4 CPUs, it will actually reserve it from your pool, and it's not usable after. It depends on how the policy has been applied. All right, did I have something else here? I think, yeah, so I could do like the same demo with InfluxDB and Grafana, for example. It's as easy to do. And there's a few things we'd like to target here in components. I mean, for example, traffic router, I would never run traffic router in OpenShift. Now I need to expose port 53, right? And I need to expose port 80 and 443, which, like, it's not something that they're going to let me do anyway. So I think it's a good fit for traffic portal, like traffic ops, if you want to actually scale those components, for example. There's Postgres in here that I've put just because we can, right? we can actually attach it to local storage, and we can also attach it to NFS. I mean, it's not like our Postgres is using a lot of resources, at least not ours, right? And traffic monitor, I put a question mark on there. I mean, if you run 3 traffic monitor, I mean, does it really matter if traffic router knows which one he's connecting to? I mean, you could load balance this connection as well.
So speaking of the monitoring, so you said a minute ago that if you allocate a CPU, then it's essentially allocated to something else. Have you, what does that mean for noisy neighbor? Have you found noisy neighbor to be an issue?
Not so far. This is fairly new, right? I think we might find that there's going to be an issue like in the future. Although I do think that they don't oversubscribe that much, right? I guess there's a policy in there. It's like, well, they can actually oversubscribe by 2 to 1 or something. For example, I brought in a log stash, and it shows up as there was 112 CPUs in that machine. So they were like doing like dual 56 core.
You know if that oversubscription is configurable like when you're setting up Openshift, or is it something that you
Yeah.
as someone making containers suggest?
Yeah, so there's 2 types of oversubscription you can do. So there's the first one is that the people that actually install Openshift could configure it's like, well, you know what, we're going to oversubscribe by twice, like 2 times. And there's also in your project, if you're allowed to, not the burst, but to use a best effort service, it's like, well, I really want 2 CPUs, right? But I mean, if the resource is not used, then it can actually be shared with other containers that I've got. That's something that's also possible. It just depends on what's allowed and what they actually allow you to do and how it's set up. And so traffic monitor, you know, maybe it would be a good thing. Traffic vault, I'm sure it could run in there. And then traffic stats is a good candidate. I think today is like, do you guys run a single traffic stat?
We have 2.
Do you have 2? And do you run at the same time, post to the same in FluxDB?
Yep.
Okay. But the data is kind of duplicated?
It overwrites itself. We did the same thing,
You
and
have the same timestamps, yeah, like something like that.
yeah,
Okay. All right. And I'm just going to talk just about this. So Grafana, Logstash, I mean, Logstash is a great candidate for this. And we have capacitor for alarming using FluxDB.
Are you using it? Are you using capacitor?
We're using it today, yeah.
For
Actually,
a lot of things or a few things?
for a few things. I mean, it's
You should
mostly
show
to
us.
generate noise, but that's about it.
You should show us. that.
Yeah. I mean, it's kind of great because it does kind of bring up alarms and scale them back down. It sends stuff to Slack, and you know,
it's a monitoring system, or
yeah, it's the alarming system for InfluxDB.
We're in
okay.
It's in their suite
Yeah.
of products.
Okay.
I spent like a week on it before, but it's been so long.
It's kind of complicated at first. right? It's not obvious, and it becomes obvious with time. But yeah, there's a lot of things that you can actually do with it. It's pretty powerful. And then I've got this thing here. Who's monitoring their Kafka partitions and offset today? And how do you do it? Manually? All right, cool. So lately I've tested this. So Burrow is, of course, LinkedIn, build this thing. So we're running a Burrow container, and actually it attaches to Zookeeper as well, right? And you can actually run multiple burrows, but it's going to know that if one is active, the other one is not going to be polling, right? And it makes itself available through an API. That Telegraph has a plugin for it, and then you can actually send this information to InfluxDB. So
Looking at that to integrate into another set of
yeah, it's kind of complicated just to do one thing, but that's what it is.
Have you run into issues with traceability and triage?
Not yet, because we're not in there really, right? I'm running Logstash in it. I've been running Logstash, like 2 containers, like for about, I'd say like 3 or 4 months in there. And I mean, it's been easy, right? And one thing is that if you need to change a setting, right, then you can either, where is it? The config map. It's like, hey, I'm going to go in my pipeline and I want to edit it. Basically, if I want to edit the pipeline, I want to change something and remove a field here. We remove a field that doesn't, there you go, blah, right? Then when you save this, depending on your policy, it might restart all your containers and redo your deployment. But all you have to do here is to go in Logstash, deploy, and it's going to redeploy that configuration. It's actually going to bring up another Logstash container, and it's going to roll them through until they're all restarted. So it's easy to kind of change configuration.
And this is also based on the idea that fundamentally your application has embraced the Docker way
Yes.
of one process is one container, standard in, standard
Yes.
out, there shall be no more.
Now it comes with other challenges, right? And it's like now it's logging. It's like, well, before I was running Traffic Monitor and I was setting up like FileBeat to get the logs and send them to Elasticsearch. Now how do you do it here, right? Now there's this notion of like sidecars where you can actually run a FileBeat container in the same namespace, you know, and the same shared file system as your Traffic Monitor, so it can actually read the file or read your logs and ship it somewhere else. So it's a little bit more difficult, and it's not as easy like, well, RPM install Traffic Monitor and FileBeat configure and go.
So nothing's never that easy.
Yeah, exactly. Yeah, so it seems like, you know, this sysadmin stuff is easy because you have full control over it. But once you actually start doing this and you've got your deployment config figured out, then it's kind of easy to upgrade.
So you guys used to use LXC, right?
We're still using LXC, yeah.
So that was kind of my question. So does this replace it or does it complement it? And kind of what are your experiences?
So this would be basically a replacement. So we're trying, like, you know, today we actually like have a few servers that we actually manage, and they're virtual hosts that we call them, right? We either run VMs on them, well, not much, but LXC containers on them. And I mean, kind of tired of managing this whole thing. Well, we'd like to find a place where we can actually bring up the container somewhere, you know, and just work. And that's kind of the goal, right? Well, these 5-6 years old server, we want to decommission them and don't have to replace them. You know, it's that kind of life cycle. So the goal is, yeah, to kind of try to do our life cycle from the physical server to Openshift, you know, possibly, and then decommission our old servers.
Does it have any, what's the shortest path between physical CPU and ASIC to process? I mean, is there,
Oh, in here?
yeah, every abstraction layer comes at a price.
So it does,
So-
yeah. And you got to be careful. And that's why I said, like, you know, traffic router, I would never run it in there, right? And that's because I want direct access and all these kind of things.
But even Traffic Monitor has some pretty strict timings.
Yeah, and this is basically NAT, right?
Yeah.
That's doing here. I mean, I don't think that's going to affect it much, right? In terms of performance, but it might. I mean, it might in your cases with like 1,000 caches. But if you're doing like 100 caches and, you know, 200
Right.
caches, it might not be a problem. And whenever you get into a distributed traffic monitor, I don't know if that's still on the roadmap or not, then this is where you would actually like break up everything, and somehow they've got to talk to each other to know who's going to pull what, right? So that could kind of help with that.
This is for development testing.
No, this is, well, it can be used for development testing, right? So I would use it in my lab for development testing, although we're planning to put some components in production on this yet. So, I mean,
Is that going to built in and
well, that's,
running on a single system, or can it operate across multiple
it's,
systems?
it takes scalability is like the goal here, right?
Kubernetes under the hood. So
Yeah.
magic.
There's a lot of magic. I mean, but the magic seems to work now. I mean, I don't know. I don't know who else has experience with Kubernetes in production. Although let's say I'm trusting a lot our IT department to manage this thing and make sure it works. Of course, we're not gonna, right, remove our older stuff and like, you know, run this right away. We're just gonna try to do this in parallel for now. Because,
So if you run on OpenStack, then it's solid.
well, so here's the thing. So OpenStack, well, you're talking about VMs or?
OpenStack is just
I was
KVM.
thinking look at OpenStack.
Yeah. So here's the thing. So OpenShift can actually be deployed on top of OpenStack, right? So there's so for example, we do have some hosts in OpenShift that are actually physical servers, and some that are VMs. So when they don't have enough physical servers, then they actually overload to OpenStack, and then also they might also burst the cloud, which is, for example, to Amazon, depending on what happens and what's your policies or SLAs for it. But yeah, it's built to scale. It's supposed to scale. All right. Any more questions? No? All right. Well, thank you.